In this module, we'll discuss unsupervised clustering. When we speak of unsupervised clustering, we're still using induction-based data mining techniques. But when we're talking about unsupervised learning as opposed to supervised learning, we're talking about techniques where we really don't have to having training data set. We don't have to have data that is already classified to build our model. We simply have to have data, and in some sense, we let the data mining algorithm work in an unsupervised manner. It can, in some sense, do whatever it wants to do. The purpose of unsupervised clustering is to group related cases together to form clusters of our cases. The cases being our customers or our patients, the instances of the data that we are interested in analyzing. And from these clusters, we wanted to see if we can determine meaningful relationships within the datasets. Perhaps all our customers live within 1 mile of Big C and love to eat spaghetti on Saturday evening. A further use of unsupervised clustering is to identify atypical instances, cases that are really far outliers. They don't seem all similar to the most of our other cases that we are analyzing. There are many uses for unsupervised clustering. Targeted marketing, again, to understand an organization's customer base. It might be a patient base if you are in a healthcare organization. To understand what different groups of people we might be working with. And then in terms that the outliers, this is a big use in terms of fraud detection in insurance and banking and other financial industries. Looking at the unsupervised clustering process, it's a little bit simpler than our supervised learning process that we went through with decision trees. We need first to assemble our data, to gather data regarding our cases. Then we present the data to an unsupervised clustering algorithm. We execute the algorithm and we review the results. We don't really go through the training data phase of building the model and then the testing data phase. We just simply see how the algorithm has organized our data. So in graphical format, you can see that I called it data instead of training data. That we present it to the unsupervised clustering algorithm, which then builds the model, and then the model gives us results. Techniques for evaluating the results to see if they're useful and if we can get information from those results that will help us to improve our business processes. The first step in the unsupervised learning process is where we are now. We need to assemble the data. That is, we need to create rows of data, each row representing one instance or one case. This is just the way we did our training data for supervised learning. And then the columns of data represent the attributes about each instance or case. Again, similar to the training data for supervised learning process. Within the unsupervised clustering process, however, all of our attributes, each of the values, colors, size, gender, each of the attributes about each our case are input attributes. These are used by the model. In this case, we are not really asking our model to do any kind of prediction. So there is no output attribute. We are just asking the model to group our cases based on the input attributes. Once our data has been assembled, and again, as we have seen, that could be quite a lengthy process, we can present the data to the unsupervised clustering algorithm. And we execute the algorithm, the data mining software. And the algorithm groups our data into clusters and builds some sort of definition of each cluster, some descriptions of what each cluster represents. Once we have our clusters, we then need to analyze them. To analyze the results of the model to figure out whether our model is at all useful to us. Keep in mind that some unsupervised clustering results might not yield particularly interesting information for our algorithm, for our organization.